Good day, ECO235 students. We begin week 2 with topic 1, linear mathematical economics problems. But before we begin, have you listened to the introductory video and read the course outline? And secondly, have you worked through the preliminary basic mathematics chapter 1 of your U textbook? So topic 1 begins with aggregate demand and aggregate supply. We will then move on to your eyes Ali model. Please note that chapters 1 to 4 of the prescribed textbook are for self-study. Hence, last week you were meant to work through chapter 1. And chapters 7 and 11 are not prescribed for the course. The remaining chapters will be worked through in the course. So we begin with aggregate demand and aggregate supply. Now, you will recall that these are topics that you would have dealt with in macroeconomics. So I will not spend much time on the theory as you will not be tested on that. However, you will be tested on applications. So there is an expectation that you are familiar with the theory. Now, the aggregate demand curve shows the inverse or negative relationship between the total real expenditure on goods and services and the aggregate price level. Now, we know that the curve would be downward sloping because of this negative relationship. The aggregate supply curve, on the other hand, shows a positive relationship between real production and the aggregate price level, and therefore it is upward sloping. Now, since we are speaking about aggregate demand and aggregate supply, we are referring to the economy as a whole. So, of course, the analysis may be similar to that of demand and supply in microeconomics. However, the aggregates tell us it is macro, and we're looking at the economy as a whole. So here, in terms of the prices, we speak of a general price level. Think of your consumer price index as an example. And in terms of your total production, it refers to the total production of goods and services in the economy as a whole. So think of an aggregate such as GDP, for instance. So when we plot the curve, you will have on your x-axis or your horizontal axis total production, and on your vertical axis, your y-axis, you will have the aggregate price level. In terms of determinants that affect your AD and AS curves, your aggregate demand is determined by everything that influences total expenditure. Thus, you will recall aggregate spending, for instance, is affected by C, I, G, D, X, and Z. So, consumption expenditure by households, investment spending, government spending, and taxes. Taxes would affect the disposable income of households, and then your foreign sector. And everything that affects these, such as monetary and fiscal policy. So interest rates, for instance, if there is an increase in the interest rates, it would affect the cost of borrowing and hence may affect consumption expenditure and investment spending. And with government policy, fiscal policy, such as taxes, an increase in taxes would reduce the disposable income of households and affect aggregate demand. So that is just your AD curve. So what affects your aggregate supply curve? Now your aggregate supply curve is governed by the cost of production, the cost of producing a total output of goods and services. So here we need to think about the prices of the inputs that go into producing a particular output. So your factors of production, such as labor, for instance, has a price that is the wage rate. And we also need to consider the productivity of these various factors of production. So for the cost of production, that would be your raw materials, your factors of production, the productivity thereof, any intermediate inputs. And if there are changes in the prices or the cost thereof, it would affect your aggregate supply curve. Graphically, let's look at our AD curve. So when we plot the AD curve, the curve is downward sloping. We have price level on the vertical axis, as mentioned before, and your total production or income will be denoted with the symbol Y, and that is on the horizontal axis. So if there's a change in any of the variables that are on the axis, we would have a movement along the curve. But if there's a change in any one of the determinants, as mentioned over here, that results in a shift of the curve. So, for instance, if consumption expenditure of households were to increase, or if government spending were to increase due to expansionary fiscal policy, we would see a shift to the right of our aggregate demand curve. And if there's a change in any other fiscal policy or monetary policy, it could also affect these determinants and hence your AD curve. So let's look at an example. So if we look at the diagram, we start with a general equilibrium position here at A, at the intersection of our aggregate supply and our aggregate demand curve. Now the 0 in the subscript indicates that this is my original aggregate demand curve before there's any change brought about. And you may be given a scenario that relates to a shift of the AD curve. So in this case, we are told that we start at point A and there is an increase in aggregate demand, and that is represented by a shift to the right of the curve. So for instance, I presented the example of, let's say, government spending increasing, so expansionary fiscal policy. So with that scenario, your AD curve shifts to the right. So what you would need to do is evaluate these 2 points. So at A, we would have had a particular general price level and total production Y. But as a result of a shift to the right and increase in aggregate demand, we now find ourselves at a new general equilibrium point B at a higher price level and a higher income level Y. So only the aggregate demand curve changed, and this was represented by a shift to the right. There was a movement along your aggregate supply curve. Now let's look at aggregate supply. Your aggregate supply curve is upward sloping, and we see the relationship between the price level and total production. We still plot our price level on the vertical axis, and we label it P, and our total production is labeled Y on the horizontal axis. So if there is a change in any of the determinants of total production or income, so these are the determinants, so the prices or the cost and productivity of the factors of production, or imported goods, imported capital goods are used in the production of goods and services or intermediate goods, that would result in a shift of the aggregate supply curve. So distinguish between the shift versus a movement. A movement along the curve comes about as a result of a change in P or Y. Those are the variables on the axis. But if there's a change in any one of the determinants, such as the cost, anything relating to the cost of production, the curve would then shift. We now look at an example where the aggregate supply curve shifts. So we start at point A, and any increase in the aggregate supply curve is represented by a shift of the aggregate supply curve to the right. So we're starting at point A, and if there's some increase in aggregate supply, the curve would shift downward to the right. So we can see that is A is 0, it becomes AS with the subscript 1, reflecting our new aggregate supply curve, and our equilibrium point has changed from point A to point B. So this brings about a new general equilibrium at point B. So what happens between these 2 points? Well, we can see that as a result, we now have a lower price level, but also we have a higher income level as we move from point A to point B. So again, please note that only the aggregate supply curve shifted. However, there was a movement along the aggregate demand curve. So you need to know what factors may cause a shift and how the curve would shift, and then evaluate what the impact on the price level and output would be. So how will you be tested? Well, the AD and AS curves or equations would be provided, and then you would need to solve simultaneously using the same process as you did with demand and supply in your first year to solve for the price level and real output. So you're solving for P and for Q. And if you are given a shift of your AD curve or a shift of your AS curve, hence you're provided with new equations for these curves, you could find out what the change or the new price level and new real output level would be at this new equilibrium. You could also be asked to calculate the inflation rate or the economic growth rate, and that would be by looking at the change in your output or your price level, depending on which you are asked, and that you can derive from your axes. So here's an example. You are given your equations for your aggregate supply over there and your aggregate demand curve. And you are asked to determine the general price level and output. So in order to solve that, you need to set your aggregate supply equal to your aggregate demand and solve simultaneously. So we've set these two equal. And now we can solve for Q by taking minus a third Q over, and it will become positive. And in order for us to add these two terms, we need to ensure that we have the same denominator, and then we can add the numerator. And now you can just solve for Q by, if you can see that this is multiplicative. So if we take it over, it will become 5 divided by 5 over 6. And therefore, you can just invert that fraction and then multiply your numerator and denominator, and you would obtain your answer of 6. Now you can take that 6 and substitute it back into either one of these equations to determine what P would be equal to, and P is equal to 3. So this is a very straightforward example. Now you are told due to an increase in consumption, the new AD equation becomes P is equal to minus a third Q plus 20 over 3. So all you now have to do is equate your old supply equation to your new aggregate demand equation. You can now solve for Q in the same way that you did previously by taking minus a third Q over to the left-hand side and solve for Q by finding your lowest common denominator and add the numerators. And then you can solve for Q similarly to the previous problem, and Q is equal to 8. And by taking Q equal to 8 and substituting it into either your aggregate supply or aggregate demand, you can solve for price level, and the general price level is equal to 4. So now this just represents a graphical illustration of your ADAS curves. So we had no vertical intercept for our aggregate supply function, so it comes through the origin. And we have our original aggregate demand curve, and that would be the vertical intercept there. And here we have our new aggregate demand curve, and that represents the old equilibrium and the new equilibrium. So how else could you be tested? Well, you could be asked to calculate the economic growth rate and the inflation rate. Now, how would you do that? So we know that to calculate the growth rate, we need a change in output. And to calculate the inflation rate, we would similarly need a change in, let's say, the price level. We normally would use the CPI index. So the principle is to take the new value minus the past value in brackets divided by the past value times 100. So this formula would be applied to both of these. So if we take our new value for output minus the past value divided by the past value, we get 33 and a third percent. And similarly for inflation, in this example, your new price level, minus your old price level divided by the past price level would also give you 33 and a third. So these are very straightforward calculations. The next couple of slides are just class exercises and homework exercises. So please take the time to work through these, and we can meet in the chat room to discuss the answers. This is the homework exercise, which would be important for you to attempt on your own, and we can check the answers together in the chat room. We will continue with the ICE-ILM model in part 2 of the